Okay, for the equilibrium part H, we're gonna test the reaction, the equilibrium, cobalt chloride. So you have the equilibrium. Then we're going to set up the equilibrium. Here you can see in the two test tube, they all have 2 milliliter, about 2 milliliter of the cobalt-2 chloride solution in there. Okay, you can notice the color of it. And then in one of the test tube, I'm going to add 1.5 grams of the solid ammonium chloride, which is here. It's already weighed. Okay, that's about 1.5 gram. Okay, so in our test tube 2 here, I'm going to add it. Okay, now I'm going to shake it, try to make it dissolve and saturate the whole solution. Okay, so you have the equilibrium set up now. Actually, both have some equilibrium. This one you could add the ammonium chloride. Actually, you are introducing more of the chloride, and it's just to make the equilibrium a little further to the right side. You can see the color, so not very obvious. The reaction is kind of slow, but we are going to have a better equilibrium when we have the chloride in there. And the first one here is act as a control. So you can see the color change by comparing to the original color. Okay, so now I'm going to put the test tube in a boiling water. So we have the water, hot water bath here. So now I'm going to put this in here. Okay, so you're gonna see what happens if I introduce heat, more heat in the equilibrium. So this part of the equilibrium test is to test the temperatures factor. Is the reaction endothermic or is the reaction exothermic? Then your heat will be either as the reactant or as the product. So in the different spot of the equilibrium, then when you increase the temperature or decrease the temperature, they're going to shift the equilibrium to different direction. Okay, so you are going to look at the color change to figure out if I heat it, the equilibrium shift to where by looking at the different color, the color change. In the menu, you can see the color difference. In the reactant side, you see that's pink. In the product side, it's blue. So by looking at the color change, you can see the equilibrium shift to where by heating it. Okay, you can see the color change started on the bottom. Okay, let me shake more. I need to shake more. Okay. So you can see that it's already started to shave. Okay. It's more and more. So dissolve them again. We need a little more of the solid. If you add a little more, too much of the cobalt, so we need more of the solid. So the color's already changed a little bit, but I wanted to heat it more to see more obvious change. It's no longer pink, it's purplish. And also don't forget the factor here is what I'm heating it. So give some time. Whoa, the color is more and more blue now. Okay, by looking at the shifting, decide the shifting, then you needed to figure out is this reaction endothermic or ectothermic. And also use this to explain the why it happened that way. Okay, now you can see the color change is very obvious, right? Okay, so you can, I'm going to take this out, to put it back here so you can compare. Look at the control. Now I heat it, it changed to what color? Okay, all right, so that's this experiment.